We're live. We're live. I'm going to welcome everybody and say hi to everybody in just a second. I do have to feed the kitty cats before I get started. Hang tight, say hi in the chat. Hopefully the live is working, and if we can get some confirmations that the live is working, that would be amazing. And we can say hi to everybody in the chat, and we can make sure all the buttons are buttoning. And we can take some physics questions and also cover some physics topics as usual. So let's get that all going. I'm seeing some, is there a lag? Hi BTS Army Wiser2. BTS Army is saying hi. Hello BTS, how are you doing? So is the video and audio working fine? Because I don't know, my face seems to be, to me, a little bit laggy. It's me, BBO. Hi, BBO. Hi, thank you for liking the live and thank you for being here. Thank you, everybody. Thank you for joining. I'm gonna say now, while I can, thank you for joining. And I'm gonna share the live as well. And I mean Bon. Hello, how are you doing? Is that Yash? How are you doing? Oh my gosh. How are you doing? Is that Yash from Pakistan? How are you doing? It's Yash from Pakistan. Oh my God, how are you? How have you been, girly? How have you been? How is everybody? How's your cousins? How's your sister? I think you had a sister, right? I'm going to share the live and say, join us, we're live. Join us, we're live. I've been fine, how about you? I'm okay, I'm all right. It's been a little busy, so I haven't always gone live as regularly as I was in the past, but here I am, and we're gonna cover whatever topics we want to cover with physics, and also the kitty cats are right here, and actually I'm gonna give them a little snack right now. I was gonna do that, but then I started the live. I've been fine, how about you? Molly, hello Molly Tilda. Molly is saying hi. Bon, you are the #1 top fan right now. They're all okay. My sis is also fine. Where are the kitties? They're here. I'll show you. So let me post this. Join us. We're live. I posted that from my other phone. So the kitty cats are right here. Suji Mama is right there. Sachi Mama. And then I moved their tree over here. And give me 1 second. I will give them a snack. And I might not move the phone, unfortunately, but I think you'll still see Baji. So hang tight. Thank you, everybody, for joining. Okay. Baji. Okay, let's have to give them a snack. Hopefully I see Agassia, how are you doing? Hopefully I see many of you joining me soon. Hopefully I see you all joining. The kitty cats are here. Maybe I'll give you a quick look at the kitty cats, if I can do that. They're all here. See, Baji, Sachi Mama, and Fuji are all here. Eating. They got their snack. Might have to blow my nose as well, as a side note. But how is everybody doing? What day is it? Is this gonna be a less busy day? Hello. Okay, so I haven't fully decided exactly what topic we'll cover because I was going to make it so that maybe we could ask the audience what topics they want to cover. I'm also grabbing my water. Welcome everybody. I'm here. Just getting my water. I'm a little sniffly all of a sudden. Okay. Let's see. Steven! How are you? I feel like I'm seeing some of my old friends and really old friends, but it might be a little late, and so maybe I have to. Okay, I'm here. Back to where you once belonged, young professor, says Ocasio. Steven says hi. Ocasio, my book goes to the presses maybe next week as soon as I send my photo to the publisher. Steven, did you take a good photo of yourself? It's exciting. So who is your publisher? Who is it? So what topic should we talk about tonight? I think, let me also do my welcoming. Welcome everybody from all the continents: South America, North America, Europe, Africa, Antarctica, Asia. What am I missing? Australia, New Zealand. Now I'm going to mention some specific places. Madagascar. Mauritius. Did I miss anybody? So, you never know who I'll welcome when, but I am ready to get this live started. And I was hoping that more people would be joining. But if you're seeing this later on as a live replay video, then that's totally fine. And please do like, share, and subscribe. I need to get my hair cut and a shave first next week. I forget off the top of my head, but it's... Wait, is it nighttime for you? Yes, it's nighttime for me. Indeed, it is nighttime for me. It's quite late. I might go live again tomorrow and start it earlier. So let me do this. Wait, what was I gonna do? Oh, I was gonna put in the chat myself. Like and subscribe. Like and subscribe. So everybody, if you're joining, please do like, and please do share, and please do subscribe. If you see this later on as a video, please do comment, please do like and share. Thank you. Steven is saying 12:35 a.m. for me and Undri. Steven does know me. Liked and subscribed already. Steven, so where are... Oh, there's Baji. See? There is... Let me point the finger at the right spot. There is Baji Baba. He has been... Hello, Iman Castlewa. Are you Lady Gaga's sister? I am. We are sisters from a different misters. Just kidding. Miguel. Hello, Miguel. How are you doing? So apparently there's some feature that YouTube actually wants me to try out. 1 second. 1 second. BTS says, I also liked and subbed. BTS, your username changes so much that I sometimes don't know which one you are, but at the same time, I was able to remember. Hello, Miguel Angle Mendoza. How are you doing? Hello, Eman. I'm related to the Trump family by marriage, says Steven. Steven, aren't you related to quite a few people? Britney Spears, Steven Spears, Trump, and someone else. There's some pilot, right? Aviation person. Okay. I don't know why I'm so stuffed up suddenly. What should we talk about today? Any particular questions or topics that people wanna discuss? In fact, if you don't pick one, then I'm gonna pick one, and it's probably gonna be astronomy. Chuck Eager, what do you think of 31 Atlas? I'm good. Oh, you know what? There is sort of a topic that I was going to discuss that I had bookmarked and collected some articles on. Actually, this reminds me. It's not the Atlas situation. Chuck and Brittany are cousins of Steven. Chuck and Brittany. I'm a little, the Comet, yeah. Crazy Sick Wine. How are you doing? Hello, Andrea. How are you on this brilliant evening? I am here. I am here. I am here. Apparently, a little bit allergic to something. I should take my Zyrtec tonight. I think I skipped it a couple nights. And what's the word tonight? What's the word tonight? What do you mean? Physics is the word tonight with my face and Baji in the background. What do you mean? You are here. La 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 la. Why is divorce so expensive? Bit is worth it? Bit is worth it? What do you mean bit is worth it? But is worth it? Let's look at the top fans right now. Number 1 is Steven. Wow, Steven, thank you so much for your excellent support. BTS Army is number 2. Crazy Sick Wine is number 3. Hello, my love. Number 4 is Miguel. Number 5 is Skeletora. Number 6 is Molly. Number 7 is Eman Castlewall. And number 8 is Acacia. And it's a little bit of a smaller crowd tonight, but no worries. We are here. We are here, we are one, we are all, we are welcome. We will be learning together and we will be conversing and we will be catching up tonight and most likely tomorrow night. And I will start it earlier tomorrow night. So sorry about that if you're already asleep and if you are not seeing this, but if you see this later on, please do drop us a comment and give us some much needed love. And this is Baji behind me, the star of this show. I'm glad all is well. I meant, what's the topic tonight? Comet is the word of the day. Can I ask what's your favorite song? My favorite song? Well, I mean, a song that comes to mind immediately is Sathiya, Tarang, Sathiya, Tarang, that one. So, I mean, if you're from Pakistan, you probably know this song. It's an Indian Bollywood song. Satya. I'm singing it very off key at the moment, but you get it. I wasn't ready to sing it, but I did it anyways. To tell you what is my favorite song, it is Satya, Satya, that one. And then also this one, Dil Se Re, that one. Can I ask what's your favorite song? I'm glad all is well. The topic of tonight is still to be decided. Crazy Sick Wine, you are in school for physics, so is there a topic that you'd like us to discuss? Please do say so now with immediate effect, because I am about to pick one if you guys don't ask a question. Hopefully an intellectual, brilliant conversation that comes about preferably on a theoretically and transverse level. Just sent me a blurb. Just sent a blurb for my book, and now they're waiting for a photo. A girl with a cold is kind of cute. I am happy that you find this cute because I don't know what it is. I think I have a little bit of an allergy because I skipped my Zyrtec for a couple nights. Why is divorce so expensive? A girl with a cold is kind of cute. Did I miss anybody's comment? And why aren't you guys asking a physics question? Dear Lord, I'm glad all is well. So Crazy Sick Wine wants to discuss something theoretical. So we might actually do cosmology tonight. Is that what? So by the way, what's your subtopic again? What's your field in graduate school right now? Crazy Sick Wine, remind me. Remind me. Is it QFT? Is it quantum field theory? Because I don't know if I can do that too well over a live. Don't see me. Don't look at me, right? Don't look at me. I'm blowing my nose. My nose is red like Rudolph the Red-Nosed Reindeer. Had a very shiny nose like me. Was it shiny or was it red? I had to refill a prescription yesterday. I was going to refill my 2 prescriptions tonight, but then I had to work on something and I have delayed it to hopefully tomorrow. I'm falling asleep. Good night. Feel better. Well, Skeletora, you should just let this run in the background to help you sleep because this lesson is also a sleep medication for many. Many have found it to be very useful to be playing this in the background. Baji in the background just relaxing. He is relaxing. He just got his snack and he is ready to relax. What is this message? Steven, don't say that word because it's getting censored. I was going to say, Steven, don't say the thing because it's going to be censored, but then I said sponsored. It's definitely not sponsored. That word is not sponsored at all. Not even close to being sponsored. Also, what is this about the 6 likes? Can we get 10 likes? Can we get 20 likes? Can we get 300 likes? Can we get $500? Excuse me, please. 12 people are here with 6 likes. I do like how 12 is a multiple of 6, but can you guys like the live? Can you please like the live? Like and subscribe. I'm also kind of sick and get coughing fits almost every second TT. TT? Second day, table tennis? What do you mean TT? Atomic, molecular, and optical. Oh, AMO? Are you an AMO? Atomic, molecular, and optical physics is my specialty, with quantum field theory being implemented as well. You're an AMO? How did I not know this? Are you doing stuff with lasers, Crazy Sick One, at MIT? Massachusetts Institute of Technology? I do miss my paychecks from that place, I will say. Never paid them, they paid me. Which is the correct way to do things, ladies and gents, because it is very expensive to study there, especially for an undergrad. Just kidding, I'm on... Oh, Steven! Well, good thing you're taking care of yourself. How is MIT going? Crazy Sick Wine. Atomic, molecular, and optical physics. I knew some people at Ohio State that did that. I went to all state schools, NC State, Ohio State, cheaper, better. It's better to work at MIT, at least for me, because I'm kind of smart too, Dre, haha. You are so smart. Everybody that watches my channel is kind of smart. I agree wholeheartedly. It's my 60th. Oh my gosh, Steven's birthday was recently. It's my 60th birthday. Wasn't it November 5th? Isn't it kind of like right now? Happy birthday to you. Happy birthday to you. Happy birthday. Happy birthday. Happy birthday to you. I started a favorite thing to do with friends poll because YouTube asked me to. YouTube wants me to use all their features. Hello. Rumi the Demon Hunter is saying, remember me? I'm Gladys. I still watch. Hello, Rumi the Demon Hunter. Hello, my darling. Hello, Rumi. How are you doing? How are you? Where have you been? I think I like this new username more. Rumi the Demon Hunter. Rumi the Demon Hunter is here. How are you? Steven's birthday is today. We're going to just call this November 5th and say that tonight is your birthday. This is Steven's birthday live because I'm kind of smart too. Yes, Crazy Sick One is also very, very smart, and he's doing AMO, or Atomic Molecular and Optical Physics at MIT. I keep trying to say MIT Lincoln Lab because that's where I used to work, but it's actually just MIT, the private and rather expensive school on the other side of the Charles River from Boston. And we're very proud of our YouTube subscribers and members here who go there or go to other schools. That's completely fine too. Was MIT my undergraduate dream school? Yes. Did I get in? No. Did I go to a school that's way more reasonably priced? Also, yes. Okay, so I still can't decide exactly what we'll cover, I must say. I need to get a new book from the library. There's a few cosmology books that I do want to get because the book that I have right now, the reference book that I've been using, is a little bit kind of too involved. So I do need to get back into the library and grab some more. By the way, guys, you can use this question thing to answer questions and whatnots. So feel free. YouTube asked me to ask you favorite thing to do with friends. So feel free to answer that if you would like. But yeah, I need to go to the library and grab a few more cosmology books because the ones that I have right now with me are kind of too detailed and it's kind of probably not the most helpful. But let me look and see which topic we can cover tonight until somebody asks a question. And then we can go from there. Oh, actually, you know what? Someone did kind of ask a question. Let's see if we can cover something about comets. Since a comet is in the news. Should we do that? I know it's more astronomy. Should we just do that? Let's do that. Someone just left the chat when I said that. So hopefully it's not because of us doing comets. But that's okay. That's okay if you have to leave, okay? You can catch this later on. We will talk about comets. Because why not? Oh, look how pretty this is. I have pretty pictures to show you as well. Look at that. So I actually myself do not know about comets. Comets is not something that I very deeply studied. But we can talk about them with the help of this book called, drumroll, we all know the name of this book. It's called Foundations of Astrophysics by Barbara Ryden and Bradley M. Peterson. So we can talk about some small bodies in the solar system. That's the chapter that this is in this book, Small Bodies in the Solar System. And if you're interested, we are indeed able to talk about this from this book. It's actually page 277 of that book, and I have it with me, and we can talk about comets because I know I've been getting this question quite a bit, and we can just generally look at comets a little bit as they're in the news. But I will say that I am not a big sort of follower of the comet business myself, but let's see. So when we observe the asteroid belt, we have an asteroid belt. So this is sort of, the chapter is called Small Bodies in the Solar System, and it has other parts that we kind of have covered in the past. Like we've kind of covered asteroids. Then there have been trans-Neptunian objects. If you remember, a long time ago we covered this. We also covered the planets, all of the planets in the solar system, in our own solar system, that is, in a lot of detail. So if you like the planets, this is not a topic that we are constantly covering. It's only some of the lives that we've covered this, but we actually did go into a lot of detail probably like several months ago. So you should look for that. And I think even have a playlist dedicated to the planets, and this probably will go in that same playlist because it's not planets, but it's still sort of in our solar system that we're talking about. So when we observe the asteroid belt, we can directly detect asteroids down to a size limit of around 1 kilometer. So asteroids can be as small, I suppose, as 1 kilometer. We can deduce indirectly that smaller bodies exist in the asteroid belt because of the impact craters they create on larger asteroids. So impact craters is also something that we've talked about. In fact, we had a heated argument at one point on this channel because of that, because there was an era in our solar system where there was a lot of cratering that actually happened. Even our moon, if you remember, has a lot of craters because the moon was hit with these types of things, planetesimals, you know, as the solar system was still kind of forming, and earlier on in its what do you call, in its evolution, we used to have these things, and the moon's surface being a lot older, because the moon does not update its surface as much as we do on Earth, because the moon would update its surface and it would get paved over if it had, say, for example, a lot of moon activities like volcanoes and things like that. But those things don't happen on the moon. But they do happen here on Earth. So our surfaces get updated and evolve a lot. Whereas if you have the same surface for a very long time, you get to see these other types of features like the impact craters. So just wanted to remind you about that before we talk further. So when we observe the Kuiper belt, because of its much greater distance, we can detect only TNOs larger than around 30 kilometers. So TNO is a trans-Neptunian object. Nevertheless, we have good reason to believe that smaller icy objects, so icy, and this ice can be different types of chemicals, doesn't have to be just water ice, but other types of ice as well. Icy objects exist in trans-Neptunian space. So what is the trans-Neptunian object? Let's just quickly define that as well. So a trans-Neptunian object, or a TNO, can be broadly defined as any object orbiting the sun on an orbit larger than that of Neptune. And where is Neptune in the solar system? It is at a semi-major axis of 30 astronomical units away from the sun. Okay? And our distance between the sun and the earth is called 1 astronomical unit in that particular type of unit. And Neptune is far, far away. In comparison, Neptune is all the way at around 30 astronomical units. And then if there are things that are orbiting the sun, smaller things that are even farther than that, then those would be called trans-Neptunian. And there are some objects of interest with regard to that. So we've kind of covered that a long time ago. But let's see. So imagine an icy body, which is around 1 kilometer across in the Kuiper belt. If we moved such a body toward the inner solar system, then once it was within about 4 astronomical units of the sun, its ices would start to sublime. So not go from a gas to a liquid to a solid, but or a solid to a liquid to a gas. But sometimes things just sublime. They kind of skip over, and they become the gaseous state, right? The resulting gases would form a large tenuous atmosphere, or coma. So it's sort of this thing which has a tail and looks like a comma that would be more easily visible than the tiny ice ball at its center. So basically what's happening is it's a thing that was a lot colder, a lot farther away, farther away, as in it could have been maybe a trans-Neptunian object with distance even farther away than Neptune. But as it gets closer to the sun, within around 4 astronomical units, and let me remember, I believe, I want to real quick, I don't want to say the wrong thing here, but we are at, obviously, we already said this, we are at 1 astronomical units away. And Mars, just to give you some idea of the distances here, Mars is at 1.52 astronomical units from the sun. So Mercury, let's just talk about the inner planets real quick to give you some distance idea. Mercury, which is obviously very close to the sun, is within 0.39 astronomical units. Venus is 0.72. So Venus is actually the closest one to us and my favorite planet as well after Earth. 1 is us, as an astronomical unit of 1 away from the sun, and then 1.52 is Mars. And Jupiter, which is kind of at the center of the solar system, or not center as in relative to the other planets, like sort of in the middle part away from the sun, is at 5.20 astronomical units. So 4 astronomical units just means between Mars and Jupiter, because the inner planets, as you know, are Mercury, Venus, Earth, and Mars. Mars is the farthest one. So there's a lot of space between Mars, which is at 1.52 astronomical units, and Jupiter, which is over 5.2, or which is over 5 astronomical units away. So in that space, basically, if something like a trans-Neptunian object kind of comes in and gets more hot, then it could develop that comma-like structure where the things are basically starting to sublime. The materials of it are starting to sublime and maybe become like that, like a tail that's easily visible. So in fact, we have just described the behavior of a comet, this type of behavior. The nucleus of a comet is an icy planetesimal left over from the formation of the solar system. So remember when the solar system was still kind of more forming, billions of years ago, a couple billion years ago, we had a bunch of these planetesimals. And some of the larger objects kind of collected them, and they became they became more integrated into the main objects of the solar system, and the solar system kind of got more cleaned up of these planetesimals. But for a long time, they were there much more, and they would impact everybody a lot and leave craters and whatnot. And we have craters, Mars, Moon, our moon, everyone has craters, and this would happen a lot. So a comet is kind of one of those types of things, one of those planetesimal objects that's kind of still hanging out. It's still kind of left over from an earlier evolution of the solar system. So the nucleus of a comet is an icy planetesimal left over from the formation of the solar system. Typical cometary nuclei are about 1 to 10 kilometers across and have a mass of 10 to 100 billion tons. Cometary nuclei are often described as dirty snowballs. So they're kind of like icy, right? Because they were, they're sort of these objects that are kind of far away, and they would have been sort of colder and more icy there. But as they move closer, that's where some of it would sublime. But so that's why they're called kind of dirty snowballs, since they consist of loosely packed ices mixed with rocky material. Spacecraft have been sent to rendezvous with Comet Halley and with Comet Tempel 1. Both these comets have nuclei that are cratered and irregular in shape. Their densities are quite low, as small as around 300 kilograms per meter cubed. And I wish that I remembered the density of Earth to kind of compare that with, but I might have to get back to that later. Indicating that the nuclei must be very loosely packed snowballs indeed. The surfaces have low albedos. The sublimation of ices has left a surface layer that consists of dark refractory rock. If a cometary nucleus comes within about 4 astronomical units of the sun, the sublimation of ices produce a coma that may be as much as 10 to the 5 kilometers in diameter. So, whoops, I moved this. So those are some of the numbers that have to do with comets. They're kind of small, but kind of not the smallest either. In addition, the sublimation releases chunks of rock and dust particles that were previously locked inside the ice. So because some of the material is subliming into a gaseous state, you actually free up some of the rock that was part of the comet, and now you have these loose things coming out. The gravitational force of the nucleus on the gas and the dust of the comet is small. Thus, material from the comet is easily driven away by non-gravitational forces. So, because there are also those types of things. So, ionized gas is swept away by the charged particles in the solar wind and forms a long, narrow ion tail. Because, you know, when you have a bigger object, the gravitational forces are much more important, and you might not be able to kind of break apart the thing very easily because its own gravitation is holding it all together, like a planet or a star, right? They're much more capable of being held together. But a comet with less mass, with some of it subliming and loose things happening, as in things coming apart and becoming looser, could actually get driven by these non-gravitational forces like the solar winds, creating an ion tail. So tiny dust particles are pushed away from the coma by the gentler force of radiation pressure from sunlight. So we also have radiation pressure from the sun because lots of photons coming out of the sun, right? So that creates radiation pressure. The dust grains from a broad curved dust tail. Thus, comets generally have 2 tails. Although from some viewing angles, so it also depends how you view the comet. I don't know what's going to happen with this comet, but they generally have 2 tails. Depending on your viewing angle, they are superimposed and appear as a single tail, depending on the viewing angle. In extreme cases, a comet's tails can be nearly 1 astronomical unit in length. So you could have a comet with a very long tail because of this type of stuff, where things have come loose and the solar charged particles in the solar wind also is part of the mix and forms this long, narrow ion tail. Comets can be divided into 2 classes based on their orbital parameters. Short period comets. So there's short period comets, and then there is long period comets. Thank God. So short period comets are those with a period of less than 200 years. So if you have a period of less than, period as in the time it takes to go around the sun, if that's less than 200 years, that's a short period comet, and hence the semi-major axis of that elliptical orbit would be around 34 astronomical units. So it is trans-Neptunian, as you can see. So this is basically an object that spends time at a distance from the sun, which is farther away than Neptune's semi-major axis. So 34 astronomical units, that's farther away from the 30, which is where Neptune is, which is kind of doing its less than 200 period orbit. Short period comets have other characteristics in common. Let's see what those are. Most short period comets have moderate inclination. Ooh, and at the end of this live, I will also show you a picture of a comet because I can see one right here. So most short period comets have moderate inclination of around 30 degrees or less, actually, though a few are retrograde. Most short period comets have fairly large eccentricity of around 0.8 is a typical value. So just some orbital orbit type of numbers. At present, there are roughly 200 short period comets known. The most famous short period comet is Comet Halley. with a period of 76 years. So that's not too short, I guess. Or too long, I guess. It is also one of the few retrograde short period comets with an inclination of 162 degrees. After a few hundred perihelion passes, a comet tends to lose all its ices. So perihelion meaning near to the sun. After it passes near to the sun, because ultimately it is going around the sun, and it's on an elliptical orbit, and it could be sometimes very far from the sun, such as at 34 astronomical units, or some points much closer to the sun. And so when that time comes, every 76 years or so, in the case of Comet Halley, depending on how many times it's kind of done this, it could actually lose all of its icy nature. Thus, after less than 10 to the 5 years, so around 100,000 years, I suppose, a short period comet becomes an inert pile of rubble. No ice left. Given this brief time scale, there must exist a repository of cometary nuclei in the cold outer solar system from which the supply of short period comets is replenished. One obvious repository is the Kuiper belt, which is known to contain icy bodies. If short period comets come from the Kuiper belt, this would explain why most of them have relatively small inclinations, which match the relatively small inclination of the majority of the Kuiper belt objects. But how can we explain the short period comets that are on retrograde objects? Retrograde orbits. To explain the origin of retrograde short period comets, it helps to consider the origin of long period comets. So now we will talk about long period comets, because we are going to finish the whole topic of comets tonight before bed. Long period comets are defined as comets with periods of more than 200 years, and hence their orbit size, or the semi-major axis, what am I saying? Semi-major, am I saying the right word? I think so. The A of the ellipse is more than 34 astronomical units. Some long period comets have periods that are very long indeed, up to 3 times 10 to the 7 years, implying the semi-major axis of around 100,000 astronomical units. So this is very, very far away. Long period comets have other characteristics in common besides their long orbital periods. So long period comets have random inclinations to the ecliptic, with as many being on retrograde orbits as on prograde orbits. Long period comets have extremely high orbital eccentricities. So very different ellipses indeed, okay, with these very different numbers. Over 800 long period comets have been detected over the course of history. The Dutch astronomer Jan Oort, I think that's how you say that name, O-O-R-T, proposed that long period comets reside in a large, roughly spherical cloud of radius 50,000 astronomical units. Centered on the sun, this distribution of cometary bodies is called the Oort cloud. And we have a picture of that as well. The radius of the Oort cloud is not negligibly tiny compared to the distance of 270,000 astronomical units to the sun's nearest neighboring star. The orbits of cometary bodies in the Oort cloud can be perturbed by passing stars. Actually, let me look up as we talk about this. Which cloud does the Atlas comet belong to? Is it a long period comet or a short period comet? I actually don't know, so I want to look it up. Hopefully I can find it. Which comet part off? Thank you for being here, everybody. It is from the Oort cloud. That's what I thought. Like I was suspecting that, but so it is a long period comet. The Atlas comet, according to Google, we should double check, of course. Let me make sure. The Atlas comet is from the Oort cloud, a distant and theoretical reservoir of icy objects at the edge of the solar system. So this is the long period comets that we have been discussing, of which the Oort cloud is something we know about. Comets from this region are known as long period comets because their orbits around the sun can take thousands of millions of years to complete. The Oort cloud, this is a spherical shell of icy bodies that surrounds our solar system, extending as far as halfway to the next nearest star. How it works: gravitational interactions within the cloud can send some of these icy objects towards the inner solar system, where they become comets as they get close to the sun. So basically these are trans-Neptunian objects that, because when they get closer to the sun, all that sublimation stuff happens, the interaction with the solar wind and whatnot basically turns them into this comet, that the behavior of that is basically a comet. Because they originate from the Oort cloud, comets like Atlas are called long period comets, distinguishing them from shorter period comets that originate from the Kuiper belt. Okay, so that's cool. I just learned that. The spherical shell known as the Oort cloud is, for all practical purposes, invisible. Its constituent particles are spread so thinly and so far from the light of any star, including the sun, that astronomers simply cannot see the cloud, even though it envelopes us like a blanket. It is also theoretical. Astronomers infer the Oort cloud is there because it's the only logical explanation for the arrival of a certain class of comets that sporadically visit our solar system. The cloud, it turns out, is basically a gigantic reservoir that may hold billions of icy celestial bodies. 2 of those bodies will pass by Earth in the days leading up to Halloween. Oh, I guess this happened already. Suchinshan Atlas, also known as Comet C 2023A3, will be at its brightest and likely visible to the naked eye for a week or two after October 12th, the day it's closest to Earth. Just look to the western sky shortly after sunset. Sorry, it's happened already. Wait a minute. I'm reading something that's kind of old, actually. This is from 2024. So you know what? I don't know. I don't know anymore. The second comet, just discovered on September 27, should be visible around the end of October. Okay. Okay. We'll keep going from the book. So it is that Atlas thing, at least that I was just reading about, is from the Oort cloud, which is part of the long period comets. The radius of the Oort cloud is not negligibly tiny compared to the distance of 270,000 astronomical units to the sun's nearest neighboring star. The orbits of cometary bodies in the Oort cloud can be perturbed by passing stars. This alters their orbits and sometimes permits them to approach the inner solar system. How crazy is that? So they're so far away that they're actually affected by the other stars, by other neighboring stars, and sometimes they're pushed inward, closer to the sun. Those few objects with perihelion distances of less than 4 astronomical units grow commas and tails and can be observed by us as comets because they're so far usually, unless they kind of become comets because they've been pushed in, making those tails happen with the commas and whatnot. That's when we would see them and we would observe them as comets. Retrograde short period comets such as Comet Halley represent long period comets that have had a close encounter with a Jovian planet that has flung them onto a smaller orbit. Because there's also the Jovian planets that are quite huge, Jupiter, Uranus, Neptune, and those things can also affect these bodies and fling them closer to the sun. The chemical composition of cometary nuclei, so at least regardless of exactly which Atlas comet I was reading about from the internet, at least now we understand how comets work more better like from the book. So thank goodness for that, and thank you for listening. The chemical composition of cometary nuclei indicates that they were probably formed about 20 to 30 astronomical units from the sun. We would know that because of the composition. If things kind of, like for example, the iciness of the object, because when you're very far from the sun, you would kind of form differently, and your chemical composition is sort of a giveaway of how far. So between the orbits of Uranus and Neptune, where the temperature of the pre-solar nebula, so the pre-solar nebula, that's where we all come from, guys, was around 100 kelvins. So that's quite low, right? So if they had formed closer to the sun, they would not have been icy. So all this, like, being so icy basically means that you're far, far away, and wait, am I live? Can people see me? I'm just now seeing the chat, and I don't even know if this was working or not. Can you see me? Did you say you went to North Carolina? It's working fine. It's been working fine because suddenly I saw the comments and I wasn't able to see them or something. So I don't even know if the whole time I've been talking whether people could see me or not, but I'll continue. So if they had formed closer to the sun, then they would not be so icy. And if they're not so icy, then when they do get flung closer to the sun, they would not form those long tails and comma-like shapes because of the interaction with the solar wind and because of things coming loose, because of partly the material subliming. All of that would not be happening. And all of that happening is what makes this object a comet, the behavior of all this. But first, being formed so far away where the material composition is mostly icy is also very important. Hello, Eman Castlewall. Thank you so much for confirming that the live is working. Thank you. I will read your comments in a bit. If they had formed farther from the sun, their water would have been locked up in solid hydrates of ammonia and methane. Right? We do know that ammonia and methane are common, especially like in those faraway planets and objects. Since water vapor is detected in the spectra of comets, this clearly did not happen. So once again, if they had formed farther from the sun, their water would have been locked up in solid hydrates of ammonia and methane. Since NH3 and methane is CH4, since water vapor is detected in the spectra of comets, so we can get spectra of comets and figure out like which lines are there or not to figure out what kind of composition the comet has. This clearly did not happen. The orbits of these small cometary bodies were easily altered by encounter with the massive Jovian planets. So once again, Jovian planets are the planets from Jupiter and onwards. So Jupiter, Saturn, Uranus, Neptune, those are the Jovian planets. Thus, they were scattered onto a wide variety of different orbits with a variety of ultimate fates. Fate, as in what happens to them. Comets on small orbits made frequent perihelion passages and sublimed early in the history of the solar system. So there were comets, there were things that were flung closer to the sun earlier, and when they made those perihelion passages, because even if it takes 100,000 years and the solar system is like 4 billion years old, that's still a lot of time to have passed close by the sun many, many times. And, they sublimed early. They're kind of done subliming and they're kind of done doing the cometary behavior. So we would not necessarily see them as comets anymore, okay? Comets on large orbits constituted the Oort cloud. So we do have this Oort cloud thing. And then another possibility is comets on unbound hyperbolic objects were able to escape the solar system altogether. So some of them actually escaped us, and if their orbit is too much like a hyperbola, not an ellipse, but it's just like just going out, then they might have even escaped, okay? So those cometary bodies that suffered only minor perturbations to their initial orbit ended up in the Kuiper belt. So one way or another, there were perturbations because of the larger planets. The Jovian planets are responsible for a lot. They are so much bigger than the rocky planets, right? The rocky planets being Earth-like, or being the immediate neighbors of our planet, that is the Earth. So Earth, Mars, Venus, Mercury, these are the rocky planets, and they're not as big. The Jovian planets, Jupiter, Saturn, Uranus, Neptune, they're really big, and they can actually either a little bit perturb or a lot perturb these types of trans-Neptunian objects to fling them closer to the sun. And if the perturbations were pretty minor, then the initial orbit ended up in the Kuiper belt, a region of relative orbital stability outside the area dominated by the Jovian planets. And if they were perturbed a lot, they might have even hyperbolaed outside of the solar system. So those are some of the things. There's a bit of a variety. Ultimately, we just have these objects that are icy because they formed far away from the sun. They're trans-Neptunian objects at astronomical units, more than 30 astronomical units away from the sun. And for some reason or other, gravitational reasons probably, either it could even be other stars kind of affecting the neighboring star kind of affecting these objects, or even the Jovian planets. They could get flung closer to the sun, and when they get closer to the sun, like within 4 astronomical units, it leads to sublimation of some of their icy materials, which gives them that comma or tail like shape, and we call that a comet. So I am not sure exactly what's up with Atlas, because I was looking up something and it said it's part of the Oort cloud. So it would be part of this larger period comet thing with the period of more than 200 years. But also when I was looking at the article, it said something about last year. So I'm not sure anymore about which is which. Did something go black? I'm only seeing this now. I'm sorry. My dad told me years ago you'd be lucky to see 1 comet in your lifetime. I've seen 4, including 31 Atlas. I missed a lot of your lives, so I don't know what type of topic you're talking about. Did you say you went to North Carolina? I did go to North Carolina not super recently. Yeah, I go to North Carolina. I have family there. Oh, are you asking about my college? I did go to NC State. When I went to NC State, I did not have family there, but after NC State, some of my family is there. Did you say you went to North Carolina? Yes. My dad told me. Astronomy is fun on certain levels. I like cherry ice. Hello, Skeletora. How are you doing? Sublime is also a word to describe the wonder and awe feeling you get from a mountain or beach sunset, for example. Indeed, I love Venus too. I found out that Chesapeake Bay has a asteroid impact crater in it. Ooh, yeah. I mean, we do have some craters on Earth, so but I'm not sure exactly where they all are. I remember the comet that struck. It's amazing that humans actually know this. We are so far away. I like to grill and chill with friends. Oh, Skeletor is sharing his hobbies. I play Cube, Rumi Cube with my mom. I understand exactly what you're saying. Let me get my notes. Halley's Comet. So I believe it's spelled Halley, okay? Halley's Comet is a short period comet. I was around in 1986 when that comet passed. Really? So did my life go totally black at some point? I'm just now reading the comments. I am undead. It's completely black. Hello, this is The Bears TV. Hello, Pat's Kingdom. Hello, Steven. You're doing marvelous. Steven said it's working fine. Thank you. Are you saying no to the I did not go all black? Oh, Eman Castle said we can see you live. Thank you. Mr. Ruha. Mr. Ruhulaziz. Mr. Ruhulaziz says hi. It's cigar shaped and the forward tip glows. Hi, how are you? Thank you. How are you? All has been clear. Live feed has been perfect. Thank you so much. Thank you for confirming. Sorry, it's been a little bit of a quieter live and I wasn't really sure because for a moment I couldn't see the comments. And we covered comets today. Kind of surprising because I usually cover more physics than astronomy. We do cover astronomy here. We cover astronomy, astrophysics, physics, cosmology, but I don't think we had covered comets in much detail, but today we did. So thank you everybody for making it to the live. If you see this as a video upload later on, please do like, share, subscribe, and thank you so much for being here. Let's see. Shall we say goodnight? Can people like my live so I have 10 likes? Thanks, teacher. I will listen. Thank you, Eman Castlewall. Thank you for coming. We will go live again tomorrow night, I do believe, and we will start it earlier, maybe 10:30 or so that we can include some more people that are maybe sleeping now. So, but either way, I hope you see this later on and find the video and leave your comments. Thank you, everybody. What time is it? 1:30. Okay. And I will probably take a picture of the comet that I was going to show you and post it on the channel so that you can have it. Good night, my friend. As soon as I get my book out, I will get your address and send you a signed copy. Thank you, Stephen. Yay. Should probably rename this Astronomy Live. Let me do that. How do I do that? Good night, Stephen. Good night, everybody. If you still want to ask anything or say anything, then feel free. I will definitely read at least an excerpt from your book, Stephen. For sure. Excuse me. I'll be right back. This has been a rather cold-filled night. I will wear my coat while I say goodnight to everybody. Maybe because I rinsed my hair. I'm used to being in the sauna when I shower. After I shower. Comet Live. Whew. No. I will put this as parts. Pick the playlist. Do you like PBS Nova? What is that? Is that a show? I'm sorry, I don't know what PBS Nova is. PBS is a channel. So, is PBS Nova a show? It's a show? I don't know what it is, sorry. Tell me something about it. Tell me what Nova is. Well, we did talk about Nova and Supernova here on the channel, and we can again. Do you like supernovae? Do you like Nova and Supernova? We can certainly talk about that again. We have in the past. I grew up near where WETA PBS airs from here in Virginia. I love Nova. Yes, it is. Comet Live. Wednesday night, it covers astrology. Do you mean astronomy or astrology, like Libra, Scorpio type of things, or astronomy? My sun sign is Libra. In case you were wondering. Let's chat. Public, Boston, physics, astronomy, invite a collaborator. Typo, astronomy. I'm a Scorpion. We know, Steven. Happy birthday. Happy birthday to you. Oh! Happy birthday. Oh, nobody did a super chat tonight. Aww. I am... Oh my god. Excuse me. I'm sorry. The phone has fallen. I don't know why. Oh, I know why. The stand has come apart. Oh, don't worry about it. It's Steven. It's your birthday. It's your birthday. It's your birthday, Steven. Happy birthday. Things have fallen apart with the phone stand. No, it doesn't include paid promotion. I have to figure out the settings of this live. No, it doesn't include altered content. Okay, save. Okay. All right, everybody. If you're just now joining, we've been talking about comets. We said hi to everybody. So if you want to say hi in the chat, or good night, goodbye, bye-bye, you can say that too in the chat as well while we're still here. Please do like and share and subscribe. And please do rewind to see the full live, okay? Happy birthday to you. My friend who does know the cat stream meowed happy birthday to me today. Aww. Can we see Baji? Of course. Here's Baji. There is Baji Baba. Baji. 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 Oh my Baji. Oh my Baji. Oh my Baji. Do you see Baji? Can we see Baji? Have you heard of Rupa and the April Fishes? They're a band. Yes, I can. We may be getting a Maine Coon. You see Baji? Yay! Have you heard of Rupa and the April Fishes? They're a band. No, I have not. Why are you asking about a band? I'm just curious. Just curious. What's the band do? Were you busy? You came live after a long time. Yeah, I'm sorry. Yeah, there were a couple contracts that I was working on that was keeping me kind of busy, but I should have some time this week and whatnot. I'm here now. I'm here. Who is this? Hello, user random alphabet. Rupa sings. You like singing. Aw. Thank you. Hi, is that B? Rupa sings. You like singing. Definitely you should come more often. Thank you. I think that's B. My username used to be B. Username alphabet is B. Hi B, how are you? And there is Baji Baba, and I've zoomed in on him, so my face is also zoomed in. Baji is in class. Hello B. B, you should rewind because we just finished our discussion on comets. I'm doing all right. Hope you in the chat are too. Thank you. I think I'll let you guys chit chat in the chat for a little bit while I pick up in the kitchen, and then I'll go to bed and you guys can all say goodnight and whatnot. E-Man Castlewall is saying, I will see you next time. See you next time, E-Man Castlewall. Thank you for coming. Please do like, share, and subscribe. Okay, my face looks so big. Good night, Steven. My face is zoomed in because we wanted to zoom in on Baji. Let's see. Would you ever date anyone that isn't in the same field of study as you? I mean, I hope so, because I haven't exactly met anyone in physics that has stuck around. Baji! Oh my goodness! Hi, Shona. Baji knew we were talking about him. He knew. He knew. He knew. Baji's jealous. As soon as you asked about dating, Baji has appeared because he wants to be the main man in my life. It is actually Baji who I'm going to marry. Baji Wawa. Mama loves you. Baji has proposed to me with this ring. See this ring right here? It's from Baji. Baji is meowing to let me know what he thinks. Baji is meowing. Baji is meowing, guys, to let me know what he thinks. Baji is meowing. Baji, oh Baji, Baji. Oh, तुमसा नहीं कोई बाजी. Baji! Oh, Baji! That's so wholesome. We are pretty wholesome around here. We are. Baji was very jealous when you mentioned dating someone. Baji is the one outside of my field that I am going to date and marry. Baji Baba, Mama's here for you. That's funny though, the dating pool in your field of study must be shallow. I mean, yeah. The dating pool is a cesspool, regardless of the field. The dating pool is a cesspool of lowly beings, regardless of the domain. So I tend to be just a cat mother who births cats. And is very happy about it. Very happy. Extremely satisfied. Baji, where are you? Where is Baji? Let's see if he comes. Sounds like hairy business. Hairy? Furry? Hairy? Baji. Ba. Where is Baji? Do you hear him? He's come back. Baji is back. Baji is back. Baji is back. Oh, Baji. Baji is back. Oh, Baji, what's wrong? Oh, Baji, what's wrong? It's okay. Can we get 10 likes? What a quiet night. What a quiet, quiet night. What an extremely quiet night. Baji's here on this stool now. So Baji's declaring the end of night and bidding everybody a very good night, okay? An extremely good night. And so we have had Comets, astronomy, and Baji tonight. And Baji is here now. Let me show you. Let me show you, and accordingly we will say good night. Good night. Here is Baji. Baji. Here. Baji. Good night, B. Baji. Baji. Baji's very comfy. He doesn't want to get up. Okay, guys. See you tomorrow. Probably a little earlier. Okay. Okay. Bye-bye. Good night. Thank you for joining. Thank you indeed. Bye-bye and see you next time, and good night. Mwah, mwah, mwah. Thank you, guys.